25 microcoulomb point charge Q1 at a distance of 60 millimeters from a plus 100 microcoulomb charge Q2. Drawn us a nice little diagram of it. A 15 picocoulomb charge Q is placed at M, 25 millimeters from Q and 35 millimeters from Q2. Calculate the resultant electrical field strength M and the magnitude and direction of the force on Q. Okay, so jumping across, we have our setup that has got Q1 here, which has got plus 25 microcoulombs of charge. And then the other side we've got Q2, which has charge of plus 100 microcoulombs. And we know this overall distance between the two is 60 millimeters. Now, they've got a point M that's actually here, and they've told us, though we don't need it for the first part, here we've got 25 millimeters, and here they've actually got 35 millimeters. Actually, we do need it for the first part. So, looking at it, first thing they've asked us for is the electrical field strength at M. So that's going to be contributed to by here and by here. But they're actually going to be opposing each other, because imagine if I put a point charge here, it's going to be repelled to the right by Q1, and it's going to be repelled to the left by Q2. So from that perspective, they're going to be opposing each other. Now the way we're going to calculate the electrical field strength is E is equal to Q upon 4 pi E naught R squared. And we've got to add those two components in. So I'm going to take out the common terms initially anyway and just go that the electrical field strength is going to be 1 upon 4 pi E naught. Now from this particular charge, we're going to have 25, Q is going to be 25 times 10 to the minus 6 coulombs. And the distance is those 25 millimeters. So we need 0.025 meters squared, because it's 2.5 centimeters, 20 to 25 millimeters. Now, acting in the opposite direction, so I'm going to give a negative sign, is going to be the 100 times 10 to the minus 6, 0.035 all squared. So that's going to be my overall electrical field strength, taking account of the first charge and the second charge acting in the opposite direction. We've then got 1 upon 4 pi. Now E naught is 8.85 times 10 to the minus 12. Same equation here, so I've got 25 times 10 to the minus 6, 0.025 all squared, minus 100 times 10 to the minus 6, 0.035 all squared. And what I've got to do then is just basically plug numbers into the calculator. So here goes. Grab the calculator. I've got 25e to the minus 6 divided by 0.025 squared. And then I've got to subtract that term, so minus 100e to the minus 6 divided by 0.035 squared. And that is all going to be divided by 4 times pi times by 8.85e to the minus 12, which gives me an answer, using the end button, of minus 374.3 times 10 to the, trying to look at that, 6, I can barely see it, volts per meter. They've given us two significant figures, two significant figures, two significant figures, so I'm going to work on the basis of all two significant figures. That's then going to give me minus 370 times 10 to the 6 volts per meter. There's my answer to two significant figures. Now, bear in mind what this means is I defined the electrical field strength as being positive to the right, negative to the left. So overall what it's saying is the field strength from this is overriding this, which makes sense. It is 4 times bigger, so the charge is 4 times bigger, but it's only less than 50% bigger in terms of a distance away. So it makes sense that this would actually override the effect. Part 2 then, it wants us to work out what the actual effect is on the point charge M. So what we've got here then is a part 2, we know the force on the charge is going to be field strength times by the charge itself. So we know the electrical field strength we've then got is 370 times 10 to the 6. And we know the charge on M, so actually on M at this point was 15 coulombs. So I've got 15 times 10 to the minus 12 coulombs. Multiply those two together. Means we've got a force, or a magnitude of a force, 360 times 10, times 10 to the 6, multiplied by 15 times 10 to the 12. And gives me 5.55 times 10 to the minus 3 newtons. So again, I've got two significant figures going into these things. So I'm going to go for an answer of 5.6 times 10 to the minus 3 newtons. Now, again, we said here, we've got the charge. This is going to be having a bigger effect than this. We knew it for the minus sign. Therefore, the direction is going to be on a positive charge. The direction of the force experience would be to the left or towards Q1. There we go. Thank you very much.